Hi guys, I just want to provide some videos to explain how each of those properties are derived. So the first one says the log with base b of a product is equal to the summation of the log of each individual variable. So in other words, you are converting a product into summation. So this property is not seen too often in some other functions, so it's pretty unique for this log function. So how do we begin to prove that one? In order for me to prove that one, if I can prove b to this power is equal to b to this power, then I can conclude that these two exponents must be equal. So with that, I'll begin with this one. So I'll begin with b to the log with base b of x plus log with base b of y equals, according to the property of powers, this is the same as b to the log of x times b to the log of y, right? So this is because this is addition and this is power, it becomes plus. It's just like 2 to the 3 plus 4 is equal to 2 power to the power 3 times 2 to the power 4. That's what I'm using. This is the property I'm using. All right. So let's continue. Move this up a little bit here. And then now, according to the a relation that we developed earlier, this is equal to x, and this is equal to y. That's a property that we proved earlier. Now I'm gonna use the same property. So you remember this is equal to x, which means b to the log b to the x is equal to x, right? So I'm gonna use the same property. So in this case, apply to this xy, which means, okay, think of this as your this guy, right? So it's equal to b to the log with the same base b of xy. Okay, so we are using the same identical property, but this time on xy. So that's actually what we try to establish, right? So this is what we have established. Now, because of that, we can conclude that these two powers must be the same. They are equal. That's exactly what we want to prove in the first property. Okay, I would like to take advantage of what we just proved to prove the next one, which is the number 3. This number 3, first of all, you want to try to describe a formula in words. That means you understand how this rule is working. So by looking at the number 3, that means if you have a power for x, say x to the power y, for this log function, you can move the power to the front of this log function. This is what the rule says, okay? And why this can happen? So it's fairly straightforward, because if you look at this power, what does x to the power y mean? That means you are multiplying x y number of times. So there are y number of x's. And then according to the previous rule, the product of the log of a product is equal to the sum of the log of each individual variable, right? So that's what you learn from the first property. And how many are there? The y number of these individual log functions are here. So therefore this is y times log with base b of x. So that's how we prove number 3. And I skipped number 2. Number 2 is actually, we will take advantage of the number 3. Alright, number 2 is very similar in some way, similar to number 1. So how do we prove these two are equal? as long as we can prove b raised to this power is equal to b raised to this power, then we can conclude that these two are equal because exponential function is one-to-one function. Now, so I'm going to start with this right hand side. So I'm going to say b to the log of x minus log of y equals, now this is equal to b raised to log b of x times b raised to negative log, missing the b base b, so log of y, right? And as you know, we just proved the second property, so this number in front of the log function can be moved to the power for the x, vice versa. So previously we say, hey, this power can be moved to the front, or it's the same as saying this front number can be moved to the power of x. So that's what we are trying to take advantage of. So the thing that you want to think of is this negative log b to the log with the base of y should be thought of negative 1 times log and then with base b of y. Now you can move this negative 1, you can move this negative 1 to the power, right? That's what we are trying to do. So this is equal to, and according to the earlier rule that we developed, this is equal to x times b to the log with base b of y to the negative 1. So please note that where this negative 1 from, it's coming from moving this guy to here. Now think of this as your x, this is your in here this is x, so therefore this is x, right? So inside the circle this is y to the negative 1, therefore this can be simplified as x times y to the negative 1, which is x times 1 over y, which is x over y. And then we are going to use this property one more time to rewrite this using exponential form, right? X over y. So that's exactly what we want to establish. That's what we want to establish. You already see that this guy is equal to this guy. Therefore, we can conclude the powers are the same. These two are the same. So that's it for this property number 3. For property number 4, which is this one, it comes directly from the definition, because we do know that b raised to power 1 equals b, right? Okay, how would you convert this into exponential form? So think of this as your triangle, this is your rectangle, right? To convert it into exponential, logarithmic form, you're gonna introduce a log, keep the base the same, and then you want to swap these two. So therefore the rectangle comes here, which contains b, and the triangle comes here, which contains 1. That's how we derive this result. The last property, there are two little equations for the last property. Let's take a look at this one. This one is saying I can rewrite an exponential function with base b into an exponential function with base e. So you're changing the base. That's why we call this as change of base formula. And how can that happen? So think about this. So b to the x, you want to rewrite that into base e, right? You need to figure out what this is. So what must be this? Let me call this as my y. Let me call this as y. So what is this? I'm going to call it y. I need to figure out what y is. I want to show that y is actually this guy, right? So now one thing is I can apply natural log to both sides to the y. And according to the property that we have, this natural log means the base e, right? So basically it's this guy. This is a short notation for this guy. And we just proved earlier one result that this power can be moved to the front. This power can be moved to the front. So in other words, actually this is going to be x can be moved to the front and y can be moved to the front. That's what we are trying to say. So after you apply that result, this is what you have: x to the natural log of b, because we say x can be moved to the front, equals y times the natural log of e, right? And this is exactly equal to 1. So that's why, you know, hey, we just say, hey, what must be this y? This y has to be x times natural log of b. That's how we prove that. So in other words, what must be true about this y? Y has to be x times natural log of b. So, and then for the very last one, this guy, I think I should leave you some room to give a try.